Okay, now for this section, we're going to be solving systems of linear equations by substitution. So previously we solved the linear equations, the system of linear equations by graphing them. So now we're going to do it algebraically. We're going to do this by hand. So there's two ways that we can do this. We can do it with the substitution method and the elimination or addition method. So this section will be doing the substitution method. So the steps for the substitution method, we're going to solve one of the equations for one of the variables. So out of the four different variables in the two equations, we're going to solve for one of them. We're going to want to pick the easiest one to solve for. Then we're going to substitute that expression for that variable into the other equation's variable. And then we're going to solve the equation with one variable. And then we're going to substitute the value back into the equation from step one to solve for the remaining variable, and then we're going to have to check our answers in both of the equations. So we'll see how we do this in an example. Probably seems pretty confusing for the steps. But when using these methods, if you recall from the previous section, we could have one answer, we could have infinitely many solutions, or we could have no solutions. So if the variables cancel and the result is a true statement, that means there's infinitely many solutions. If the variables cancel and the result is a false statement, that means there's no solutions. Okay, so let's do some examples. So solve using the substitution method. So we have the system 5x minus 4y equals 9 and x minus 2y equals negative 3. So the first step, we're going to solve for one of the variables. We can pick which one we want to solve for. Let's look at this equation here, because if we solve this for x, that is going to be the easiest because there's no coefficient multiplying the x. So if we solve this for x, it's going to be starting with x minus 2y equals negative 3. We have to add 2y to both sides, so we get 2y minus 3. So what we're going to do is we're going to take this and substitute it back into x in the other equation, which is right here. Okay, so that's going to be 5x minus 4y equals 9. So instead of x, we're substituting 2y minus 3. So now this gives us one equation with one variable, so we can solve it like we used to, like we normally do. So we distribute the 5, so 10y minus 15 minus 4y equals 9. 10y minus 4y, we get 6y minus 15 equals 9. Then we have to add 15 to both sides. That gives us 6y equals 24. Divide both sides by 4, that gives us, or divide both sides by 6, that gives us y equals 4. So that's one of our answers here. To find the other one, we have to take this and plug back into, we already solved for x in terms of y right up here. So we're going to take that and plug it back into that. Plug back into x equals 2y minus 3. So it's going to be started up here. So x equals 2y minus 3. So we plug in 4 into y, so 2 times 4 minus 3. That gives us 8 minus 3, so that gives us 5. So this is going to be our answer. It's going to be the solution is x equals 5 and y equals 4, or we can think of it as a coordinate 5, 4. So you could check your answer if you want to plug it back into the original equations, both of those x and y coordinates, and make sure that it works out. So if we graph this, I'll graph x minus 2y equals negative 3. So that would look something like this. And then if we graphed the other one, 5x minus 4y equals 9, that would look something like that. And then you can see their point of intersection here is the answer, which is 5, 4. Okay, so a couple more examples. So 3x plus 2y equals 4, and 2x plus y equals 1. So we get to choose what variable we get to start with. So once again, we want to choose the one that does not have a coefficient other than 1 on it. So the one that we're going to solve for that's going to be the easiest is going to be the y in this second equation. So we're going to solve this for y. So it's 2x plus y equals 1. So to get y by itself, we have to subtract 2x on both sides. That'll give us y equals negative 2x plus 1. We're going to take that and plug into y. We're going to plug in this part, this expression, into y in the other equation, which is this y right here. So starting with 3x plus 2y equals 4, and now plugging in that expression for y, 3x plus 2 times negative 2x plus 1 equals 4. Now we have one equation, one variable, so we can solve that for x. So it's going to be distribute that 2, we get negative 4x plus 2 equals 4. Combine like terms, negative x plus 2 equals 4. Subtract 2 on both sides, we get negative x equals 2. So we would divide both sides by negative 1, and we get x equals negative 2. So now we have to find y, so we're going to take this value, and we're going to plug back in to that equation that's right up here. We're going to plug back into y equals negative 2x plus 1 to find y. I'll do that right here. So it's going to be y equals negative 2x plus 1. So we plug in x, we get negative 2 times negative 2 plus 1. That's y equals 4 plus 1. That gives us y equals 5. So the solution is the xy coordinate, negative 2 comma 5. Okay, and then for the next one here, we have negative 3y equals negative 2x plus 4, and 4x equals 3 minus 5y. So choosing which variable to solve for here, you can choose any of the 4. None of them have a coefficient of 1 on them, so it might be a little bit hard to solve for. So what I'm going to do, I'm just going to choose to solve for x from this first one. You don't have to choose that one, but that's the one I'm choosing. So negative 3y equals negative 2x plus 4. So we would add 2x to both sides, and then we would add 3y to both sides and get this. We would divide both sides by 2. We would get x equals 3 halves y plus 4 divided by 2, which is 2. Okay, so we're going to take this portion right here and substitute that back into x from the other equation, which is this x right here. So starting with 4x equals 3 minus 5y. So plugging that into x, we have 4 times 3 halves y plus 2 equals 3 minus 5y. So solving this for y, we have to distribute the 4 on the left side. So 4 times 3 is 12. 12 divided by 2 is 6. That's 6y plus 8 equals 3 minus 5y. I'm going to add 5 to both sides, and I'm going to subtract 8 from both sides and get 11y equals negative 5. Lastly, I'm going to divide both sides by 11 and get y equals negative 5 over 11. Okay, and then we're going to take this and plug back into that equation that we already had solved for y, or solved for x, sorry, all the way up here. So we're going to plug back into x equals, so 3 halves y plus 2. Yep. Okay, so starting with x equals 3/2 times y plus 2. So we're going to plug in -5/11. And we get 3 times -5 is -15. 2 times 11, 22. So -15/22 plus 2. So we would have to get common denominators here, a common denominator of 22. So it'd be, instead of writing 2, we could rewrite 2 as 44/22. So 44/22 plus 15/22 would end up giving us 29/22. So we get fraction answers here, which is okay. So that's going to be our solution with x and y. The solution is the coordinate 29/22, comma, -5/11. Okay, next one. X equals 5 minus 2y and 2x plus 4y equals 6. So we actually already have x solved for right here. So we can plug the expression 5 minus 2y into this x in the other equation. So we have 2x plus 4y equals 6. So this one was a little bit easier because we didn't have to solve for one. It was already solved for. So we plug in for x, we plug in 5 minus 2y plus 4y equals 6. And we distribute the 2 and get 10 minus 4y plus 4y equals 6. And we probably recognize here that these y's actually cancel. -4y plus 4y equals 0y, so 0. We're left with 10 equals 6. So if you remember from before, we said if the variables cancel and we get a false statement, that means there are no solutions. So that's what happens here. 10 does not equal 6. So we have no solutions. Okay, and let's do one more here. We have 3x minus y equals 4 and -9x plus 3y equals -12. So let's pick one to solve for. So we have a coefficient of -1 on the y here. So let's solve this for y. Probably will be the easiest. So 3x minus y equals 4. We're going to add y to both sides, and then we're going to subtract 4 and get y equals 3x minus 4. Okay, now we're going to substitute that expression in to the other y in the other equation, which is right here. So with the other equation, we have -9x plus 3y equals -12. So plugging in for that y expression in terms of x, it's going to be 3x minus 4 in parentheses equals -12. Then we solve this for x. We have to distribute that 3, so we're going to get plus 9x minus 12 equals -12. So once we get to this point, once again, those variables are going to cancel, and we're left with -12 equals -12. So this time the variables canceled, and we got a true statement. So if the variables cancel and we get a true statement, that means these equations are actually the same and there's infinitely many solutions. Okay, so that is it for the substitution method.